Hello everyone, welcome back to the computer network series. Today we are going to learn circuit switching versus packet switching. Why do we need different switching techniques like this? Suppose you want to talk to your friend. Should the communication path be reserved only to you and your friend, or should it be shared with others? This question introduces two switching techniques, namely circuit switching and packet switching. This circuit switching is a communication technique in which a dedicated communication path is established between the sender and the receiver even before the data is being transmitted. Fine. So assume sender A and receiver B. Before the data transfer, a dedicated path is being set up between A and B. This path remains reserved until the communication is over. For example, our traditional telephone networks. You dial up to the receiver picks up. Fine. It means that already a dedicated path is being reserved to you and your receiver. You communicate and then you finish communication and put down your phones. Fine. So this is a typical example in which a dedicated path is being reserved between you and the receiver. Data is being transmitted after which, and after data transfer, the dedicated path is being released. Few real world examples of circuit switching include landline telephony, as we discussed, dial-up internets, early video conferencing systems, and the T1E1 lease line systems. Fine. Coming to the phases of circuit switching, there are three phases. Number one is a connection establishment phase. This phase, a dedicated path is reserved between the sender and the receiver. In this phase, no data is being sent. Number two is a data transfer phase. Once the path is established, all data follows the same route. So between A and B, there is a reserved path and there is only one route. Number three is connection release. After conversation is over, this dedicated path is released after communication. Fine. So these three are the phases of circuit switching. Done. Coming to the characteristics of circuit switching, there are few important characteristics which include dedicated bandwidth. Yes, there is a fixed communication path between the sender and the receiver. True. There is no packet loss due to congestion. Why? Because the path is always reserved. There is a constant delay, and this is typically suitable for voice communication. Talking about the advantages, this gives guaranteed bandwidth. There is a predictable delay always, no out of order delivery of data, high quality voice communication. What could be the downside? The disadvantages include bandwidth is wasted during silence. Setup is required. There is a negotiable amount of time required for setup. Poor scalability, and it is not suitable for the bursty internet traffic like today's traffic. Yes. Let us see a typical analogy. Imagine you book an entire railway track for one train. Even if the train stops midway, no other train can use the track, is it not? Yes, so you are not using the bandwidth efficiently. This is circuit switching. Yes. Moving on, what is packet switching? Packet switching is a communication technique in which data is divided into smaller units called packets, and each packet is transmitted independently through the network. The internet uses packet switching. For example, we have already seen this. Suppose a file of 10 MB needs to be sent over the internet. Instead of sending it as one large file, it's divided into packets like packet 1, 2, 3, 4, 5, etc. And each packet will be sent through the network in different paths, and though it takes different paths at the destination, all packets will be rearranged in order. Yes? Right. So the packet switching has three phases. One is called the packetization, where the big data is being divided into smaller chunks called packets, and the routers route the packets through the internet, finding the best path dynamically, and at the receiver or the destination end, the packets are reassembled. Fine. So comparing dedicated paths, that is the circuit switching, versus the dynamic path, that's the packet switching. Circuit switching guarantees bandwidth. there is a constant bit rate. There is a dedicated physical link between the sender and the receiver. Whereas packet switching gives efficient resource sharing, is very adaptive since it is taking multiple paths, and it is very much suitable for bursty data transmission like the internet. Coming to the characteristics of packet switching, there is no dedicated path, yes. Bandwidth is shared by many users, yes. Routing is dynamic. Efficient resource utilization is achieved. It supports millions of users simultaneously. That's a very important characteristics. Talking about the advantages of packet switching, its efficient use of bandwidth, it's highly scalable, fault tolerant, because one route fails, the packet can be rerouted in the alternate route. Packet switching supports data, voice, and multimedia contents. Talking about the disadvantages, delay is variable, congestions may definitely occur, packets may arrive out of order, and packet loss is always possible. Talking about an analogy for packet switching, let us assume a courier company which sends large shipment in many small boxes. Some boxes travel by road, others by air, but all boxes are reassembled when they reach the destination. So this is a typical example for packet switching. Yes, let's compare circuit switching and packet switching. What about the path? It is dedicated in circuit switching, whereas the path is shared in packet switching. Setup, it is required in circuit switching, whereas no setup is required in packet switching. What about bandwidth? Bandwidth is reserved in circuit switching. Bandwidth is dynamically shared in packet switching. What about delay? In circuit switching, delay is constant, whereas in packet switching, delay is variable. What about resource utilization? Circuit switching resource utilization is low, whereas it is high in packet switching. Talking about reliability, high for continuous communication, whereas packet switching high though alternate routing is being done. Circuit switching is suitable for telephone calls, typically voice communication, whereas packet switching is suitable for internet, email, web, streaming, multimedia content also. Fine. Coming to the end of class question, why does the internet prefer packet switching? So we have compared circuit switching and packet switching, and we understood that the internet uses packet switching. Now the question is, why does the internet prefer packet switching compared to circuit switching? What could be the answers? Because packet switching has better bandwidth utilization, supports many users, it is more reliable because of the alternative paths chosen, and it is less cost.